Hello, everybody. Hey, this is going to be a help video on week 3 problem set 1. Okay, and those problems were 5, 7, 21, 25, 39, and 57. Okay. And I'm going to probably spend most of my time going over problem 39, which is definitely going to be the trickiest. But just a quick thing on problem number 5, they're giving you x and y, and then there is r, and there is theta. So remember, basically what they're asking you to do is convert, even though you do not know the actual numbers, you can still get this. Remember that the square root of x squared plus y squared is equal to r. An inverse tangent of opposite over x is equal to theta. Okay. Now remember, they're giving you some positives and negatives, there. And so since you've got x and y, the tangent is going to give you a positive answer in the first quadrant and the third quadrant. Okay. And that's going to give you the reference angle. So you have to kind of deal with that when you are putting it in here. And then if you do inverse tangent of x over y in the second quadrant or fourth quadrant, it's going to be negative. So if you just get your angle and you can just kind of get that reference angle. So for example, if you went down 2 but over 1, okay, so you had negative 2, 1, and that might say 2x and positive y. 2x and positive y. I would just concentrate on getting this angle, that angle right there, okay, and just think of it as in absolute terms, and then you can say the inverse tangent of the opposite, which would be y, over 2x, okay? Well, remember, it's really just talking about the coefficients there. So this x and y, you're not worried about the x and y because they are going to be unit lengths. They're going to be 1. So this is going to be just inverse tangent of 1/2. Well, if you get inverse tangent of 1/2, that is that angle right there. So that's going to be with respect to this negative y-axis. So if you wanted the overall angle, you would essentially add 270 to it, okay? Or you could take this one and get the negative one, but that would be the negative of the complement if this is theta and that's phi, phi plus theta is going to equal to 90 degrees, being a complement. All right, so problem number 7. You guys, problem number 7 is really just a standard application of trig. So if you're sitting over here and you are looking directly across and you want to know how wide the river is, okay, you're going to go down a certain distance and then you measure this angle. And I think in this case, you've got 35 degrees and you've got 100 meters. So now you're just going to use a little trig there. So if this is the opposite over adjacent, that's going to be tangent. And so you can say tangent 35 is equal to x over 100 and just solve for x. Okay, so that was number 7. Now we have problem 21. And obviously the answers are in the back of the book. 21. You are exploring a cave. Okay. So essentially, what you're going to have is you're going to be at the entrance of this cave, and then I think they have you go north and then east and then northeast, and then south, okay? And what you want to do is convert all of those distances into their x and y, So when you do that, for example, the very first question, or the very first one that they give you, is 75 meters north, okay? So remember, in this, you're going to say I is equal to east and J is equal to north. So this first trip there, if you call it A, then A is going to be equal to, well, you're not going east, so it's going to be 0I 25J, okay? And then you're going to get B and C and D, and then when you add them up, you're going to get the coordinates. You're going to get the coordinates to where you end, okay? And then you can use some trig and figure out the hypotenuse, because the question is asking you find her resultant displacement from the cave entrance. The resultant displacement from the cave entrance. Okay, now 57, you guys, 57 is very similar to that. It's just kind of the same exercise, and it's perhaps a little bit easier. You're going to do the same thing to find the displacement, but I think in 57 they're also asked for the distance. Now remember, the distance is going to be the length of the actual path. So you're going to add up all of those actual lengths, and that's going to give you the distance, where the displacement is going to be the difference between where you end and where you start. Okay? All right. So if you've got that, now let's talk about, sorry about that. Now, you guys, I think all we have left is 39. Now, 39 is definitely one that's going to make you think a little bit more. And so let me read you the problem, and we'll do it from start to finish. Okay, so we're going to have this ship, okay? And this ship is, okay, starting to sink. And so they are going to, they're going to radio to a station. Now the station is going to be, let me get these numbers correct. A radar station locates a sinking ship 13.7 kilometers at a bearing of 136. Okay, so from the station, from the radar station, they're going to take a bearing of 136. So when you hear bearing, you should be thinking north, south, east, and west. And when you have north, south, east, and west, remember that north is your standard position, and that would be 0 degrees. And it's not going to go counterclockwise with the angles like it is in a Cartesian plane. It's going to go clockwise. So what we're going to go here is we're going to go 130. See, 136, sorry about that. 136 degrees, okay? Well, here is east, and you know that that's 90 degrees. So what you basically have here is a reference angle that is equal to 46 degrees, okay? And you know that the length here, the hypotenuse, is going to be 17.3 kilometers, okay? So now, the radar station is going to radio a rescue ship, or a rescue plane, okay? And that is going to be 19.6 kilometers from the radio station, and that is going to be at a bearing of 153 degrees, okay? So now we're going to go 90. This is going to be an angle of 153 degrees, okay? Now, if we take this reference of south being 180 degrees, we can take 180 minus 153, and we're going to get a reference angle of 27 degrees, okay? So now, really what the question is asking is write a position vector for the ship relative to the plane. Okay, so let's first figure out where the heck those are in coordinates. Where are those in coordinates? And then we can figure that out. Okay, so we've got this one, which is 19.6 kilometers. Okay, so we're going to make this a reference angle. We're going to make that a reference angle. So if we go 19.6 sine 27, okay, sorry, 19.6 sine 27, we're going to get 8.898. We'll call it 8.9, okay? So that's equal to 8.9. And since that's going in the east direction, we're going to call that I, kind of in the same way we did with that other problem. So if we go 19.6 cosine 27, 19.6 cosine 27, 19.6 cosine 27. What is going on here? 19.6 cosine 27. We're going to get 17.46. We'll call it 17.5. Okay, 17.5. All right, so these are the coordinates, and this is J. Okay, and now we are going to get the coordinates for this one. So now I'm just going to use a different reference angle. So now I know that this is 46 degrees. So if I say, what was our 17.3? 17.3 sine 46. Okay, well that is going to give me 17.3 sine 46, 12.4, 12.44, we'll round to 12.4, 12.4. But remember, that's opposite, so this is actually J. This is going up and down, so we're going to call that J. That would be south. And then we're going to say 17.3 cosine 46. 17.3 cosine 46, and that's going to give us 12.017. We'll call that 12, 12.0, and that is moving in this direction. Okay, so now if you're paying attention, I've made a couple of mistakes that I will fix here when we kind of formalize it. We want to know this is now becomes our new origin, and we want to know where this ship is with respect to that. So we want to know the difference. We want to know the difference between the ship and where the rescue plane is. Okay, so we're going to say ship, and it is going to be 12.0 I and minus 12.4 J, because remember, it's going in the south direction, so that is negative, okay? And we're going to take a look at the rescue plane. Rescue, okay? And that is going to have coordinates of 8.9 I and 8.9 I and 17.5 J, okay? And this is positive I, but it's negative J, okay? Now the ship is going to be at 0, and the plane, I believe, is going to be at 2.2 kilometers, so 2,200 meters above. So that means we're going to have plus 0K, and then we're going to have plus 2.2K, and we want to know the difference between those, okay? So we're going to take 12 minus 8.9, and 12 minus 8.9 is going to be what, 3.1 I, and 3.1 I, 12.4 minus a negative 17 is going to give us, was that 5.1? 5.1 J, and 0 minus 2.2, which can be minus 2.2 K, and all of that is measured in kilometers, and that is your position. That is your position. So, and now this is going to make sense. And if you mess this up, okay, and you kind of did it the other way around, if you think about where we are right here, where the rescue plane is, okay, then it's going to end up having to go over 3.1 in this direction, positive, and up 5.1 positive, okay, and that is going to give us this. And it's also going to have to go down in elevation. It's going to have to go down in elevation. So this is going to be, that's going to be where our position is. Now, we're not quite done with the problem. And it says, how far apart are the ship and the plane? How far apart are the ship and the plane? And they're this far apart, right? But this is in the coordinate system. And what we're going to do here is we're going to say the absolute change in position. Okay, the change in position. Now remember, we essentially made this 0, 0. Okay, and we're going to use Pythagorean theorem. And we're going to say 3.1 squared plus 5.1 squared plus 2.2 squared. Now, this is negative, right? But if we put in negative 2.2 and it gets squared, that's going to turn positive. So if you didn't know that the Pythagorean theorem works in 3 dimension, as in a squared plus b squared plus c squared equals d squared, it does, okay? So we're going to say 3.1 squared plus 5.1 squared plus 2.2 squared equals, and then we're going to take the square root of that, and we're going to get 6.36, and let's call it 6.4. So this is going to equal to 6.4 kilometers. 6.4 kilometers. And I think that that answers the question. And we could do, you guys, we could do an angle. We could do an angle right there, but it really doesn't ask us for it. But that would be the inverse tangent. That would be the inverse tangent of 5.1 over 3.1. Okay, and that would give us the compass bearing, and then we could figure out if we wanted to at what angle we would have to go down. It would be inverse tangent of 2.2 divided by 6.4, and that would give us the angle down. So if you're dealing with the direction in 3 dimensions, you need 2 angles from the horizontal plane and then from the vertical plane. All right, I hope that helped, and I think that was the trickiest problem. And we will see you next time. Take care.